Today in this video we are going to study about logarithms and its properties. But before I start anything, kindly subscribe my channel and comment because your comments are very valuable for us. So we are going to cover the standards ASSE 2 and FIFC. The success criteria of this lesson is to convert the logarithms forms to exponential form and vice versa. Also to evaluate the logarithmic functions using calculator and as well as by the mental man, and also to determine the acidity or basicity of a chemical by finding the logarithms of the hydrogen or hydroxide ions. Now the question arises that why do we learn logarithms? Actually the logarithms are very important not only in the science but also they are important everywhere in the world. They are helpful to calculate the things like radioactive decay rates, financial interest, rocket fuel requirements, chemical reactions, and so on. So in order to understand what logarithms are, it is very important that your concept about the exponential function should be clear. So for example, if I give you a very simple example of 2 to the power 3, means 2 raised to the power 3. If I ask you what is this equals to? So you know that 2 raised to the power 3 can also be written as 2 is to 2 into 2. It means 2 times 2, 4, and 4 times 2 equals to 8. So very simply you will say that 2 raised to the power 3 is equals to 8. But if I ask you that what do I raise as a power of 2, means if the 3 is unknown, if I ask you that what do I raise as a power of 2 so that I get 8. So in order to simplify, of course, you will make the bases alike. So here you can write 2 to the power x equals to 2 to the power 3, which is equals to 8. Now since the bases are alike, we use the logarithm concepts, which I will tell you later on. We can say that x equals to 3. If the bases are alike, we always say that the powers are equal to each other. But how did we get this x equals to 3 without making any operation? So understand that exponential functions are the inverse of logarithmic functions. So our logarithmic functions are the inverse of the exponential functions. So if we are taking the example of 2 raised to the power of 6 equals to 8, and as I said that logarithms are the inverse of the exponential function, I can write it in the form of log as log of base 2. Here the base is 2 for the exponential function. So I will write the base of the log over here near the g. Of 8 equals to x. So log of base 2 of 8 equals to x. And even if you use the calculator to calculate this thing, you will get the answer, and it will be 3. Now how do we do it normally? So if in general, let's generalize the formula. In general, if it is written as log of base b of y equals to x, we can say that base b to the power x equals to y. So this is the general formula of logarithm. So here you can say log of base b of n equals to a. If we write it, then we can say that b to the power a equals to n. Or in the other words, you can just rotate your hand anti-clockwise in the anti-clockwise direction and automatically the conversion will happen. Now let's convert some of the exponential forms to logarithmic forms. So 2 to the power 7 equals to 128. So how do we write it? So base is 2. So you write here first the log. Since the base of the exponent and base of the log should be same, so always start with the base and write here the base 2 of 128 equals to 7. So rotate your hand in anti-clockwise direction. So similarly in the second question, you can say that log 64 to the power 2 by 3 equals to 16. So in order to convert this exponent into the logarithmic form, you will write log of, start from the base that is 64, then go to the other side which is out of the equal side, on the other side of the equal sign, that is 16, and then you put equals to 2 over 3. Now let's take another example. So here you have log of base 3 of 1 over 81 equals to negative 4. So here what you will write? You will write here log. What is the base? The base is 2. So you always start with the bases. Then 2 of 512. Rotate your hand in anti-clockwise direction. That is 512. Then two terms are written. After that, just put the equal sign. Now what number is left? That is the power. That is equals to 9. Here what we will write? We will write as log of base. What is the base our? Our base is 1 over 7 of what? 1 over 343 equals to 3. So let's try yourself. Here what we will write first? We will write log. What is the base? The base is 7. And then of what? 1 over 49 equals to, what is the answer? That is negative 2. Now let's check how to convert the log to exponential form and vice versa. Understand, you have to rotate always your hand in anti-clockwise direction. You write two terms first, and then after the equal you write one term. So in this way you can understand, or you can remember this conversion. So how we will start? We always start your conversion, start from base. Whether you are converting the log to exponential form or exponential to logarithmic form, always start with the base. So here the base of the logarithm is 15. So you can write here 15. 15 raised to the power 2. You move your hand in the anti-clockwise direction, 2 equals to, 15 to the power 2 is 225, and that's your answer. Let's do another one. So here, start from the base, move your hand in the anti-clockwise direction. So you will write 3 to the power of negative 3, and then put the equal signs and write the remaining thing, that is 1 over 27. So this is the play of only 3 digits. Okay, so next here you will start from the base, raise to the power, which is the number that is on the other side of the equal sign. So you will say 4 raised to the power 5 over 2 equals to 32. Let's move to last kind of today's lesson, that are the types of logarithm. There are actually 3 types of logarithm: common log, natural log, and binary log. But here we are going to teach you right now common log and natural log. So common log, if you will see that anything with the base 10 is said to be common log, whereas anything with the natural exponential base log of e, the value of the natural base or natural exponent is 2.782, and log e can also be written in the form of ln. So ln of x equals to 1. So understand that any log having the base 10 is said to be common log, whereas any log having the base e, that means the natural exponential function, is said to be the natural log. Any other base, they are the binary logs. So convert the logarithms to exponential and vice versa. So as I told you that always start from the base, then go to the, move your hand in the anti-clockwise direction, raise with the power of 3, and 4 raised to the power of 3 equals to 64. Now here what we will write, 3 to the power 5 equals to 243. Now last, that means 5, move your hand in the anti-clockwise direction, that means 5 raised to the power negative 2, which is always equals to 1 over 25.